Um,
Yeah.
yeah, so just to introduce myself, for those of you guys that don't know me, my name is Dawn James. I'm serving as development director at Repowering Schools, and just really happy that you all have joined us today, and look forward to the discussion from Todd, and also just kind of giving you a little bit of a heads up and what we're doing. So first of all, welcome. Thank you so much for joining our College Student Network session. So this is just really about giving you direct access to the industry. We're going to talk about what's happening, where the opportunities are, and how you can kind of plug into those opportunities early. Okay. So one of the things that is really valuable about Repowering Schools is the things that we offer, the programs that we offer that give real exposure into the industry. And a program that I was grateful enough, had the pleasure of running recently, is our conference experiences and student symposia. And so these aren't, just just attending a conference. It's an opportunity to meet developers and operators and executives and really understand how projects work, how things actually get done in the industry. And most importantly, and I'd say, in working with students, is building your network early. Being able to understand how your actual major translates into a job, and what you do in that job and how you use your education in that job. Very, very important. So we'll have open applications to these events. So it's the WISE Leadership Forum. I've gone to this conference for years. And it is one of the best conferences for early professionals that if I have to, kind of name all, it's the best one. It's very much geared to early professionals. There's just a lot of people in the industry, and you just learn a lot. REpS is another great one. And of course, American Solar Energy Society, that's coming up. So we'll have open applications. And I would absolutely suggest anyone, especially if you're kind of near in that area. Some of these we do have travel grants for, but get your applications in, get them in early, and participate. The other thing that we currently have the Energy Academy, which is open. The deadline is today, I believe. Its deadline is very soon. This is for students currently enrolled in college. It's a 5-week program. It's working on real world challenges in the solar development and community, and doing community engagement projects. It's learning directly from industry professionals. It's sponsored by Google. So Google employees are participating in the program. And it's also giving you a hands-on field experience. This is great opportunity, put on your resume, getting into the industry, no prior experience is required. And we're looking for people that are curious, have interest, and most of all, have that level of commitment. So if you're thinking about it, strongly encourage you to apply to that. Um, and then one of the other things that we have going on is our seed funding. This is an exciting opportunity, and this is an AES supported opportunity. We offer $20,000 total to 4 students, and they receive around $5,000 each. And again, this is real projects, bringing them to life. It's great to put on your resume. And what's super important here is that we're not, just giving out the funding. It's about supporting the learning process through a series, and helping you to build out a strong proposal, and being able to move from just the learning that you get in school to how you actually apply this in real world scenarios that will help you when you get into the field, into industry. We have a couple new programs, so we're continuing to expand how we support students. And this is beyond just individual programs. We have Repowering Careers, which is focused on specifically career placement, and supporting you to be able to get jobs. And then we have Repowering Forward, which is building a strong alumni community and ambassador network. And this is really important. So, like, after you have gone through our program, participated in numerous programs that we have, gotten a job, you're in industry, we still hold together the Repowering Schools network, which is really important so that you can still you can kind of grow up in the industry with your peers and you can help bring people up, but then you can also connect with people that are in similar industry that you are, and you guys can continue to support each other. So we keep you all together virtually as things move forward. Um, and then we also have our Renewable Energy Education Awards, where we recognize leaders across education, industry, and also students. So our goal there is to support you beyond school, but also as you move into the industry. Okay, and then yeah, so I mentioned the education awards. So if you have anyone that you'd like to nominate, we are certainly accepting nominations. So please nominate somebody today. We're certainly looking for people that deserve recognition. Um, Lastly, we certainly would love your feedback. We're evolving these programs. Any sort of input matters, especially, so we make sure that we are developing these programs in a way that serve the student and professor community and the schools that we work with, and also our industry partners that we serve in the right way. So we appreciate your feedback, so that we can continue to improve the experience and do what's valuable to you. Um, we do record these sessions, so we're recording now, and they're shared on YouTube. So if you miss anything or you want to go back and review anything, you always have access, and feel free to share this around your network. So if you know people that might be interested, feel free to, access the YouTube and share those around. Okay, and then this is the YouTube page. Feel free to share that. And then, yeah, so we'll pass it off to Todd. I don't know, Charles, if you have a little introduction, and we'll
Yeah,
move forward.
I'd love to say a few words. I mean, I know Todd will tell us about himself, but what I find amazing about, when I look into who Todd is that it seems like this is his job since he got out of college, right? And so it's been a long time gig. And that says a lot about two things. One, it says a lot about Todd and that, the people love him and they keep promoting him to keep him in the organization, but it also says just as much about Mortenson and how they have a culture which makes people want to stick around. And I just think that's amazing because this whole notion of putting your career into one company we don't hear that much about it. People are kind of vagrant and so I'm always really encouraged when I see people who've stuck it out and because I see it as this bidirectional beneficial thing. The second thing is Todd has this really long history. And if you look back, was it in '08 or something when you kind of entered the scene, '08, '09? And if you think back in '08, '09, that was kind of like it was when we stopped messing around with the PTC and we kind of let it stick. And so that's when the industry started to take off. That means that Todd's been in this thing since we kind of actually got it in the second gear, if you look at it that way. And that's a big deal. That means that Todd has seen the arc of the industry in a way that few people have. And then I'm going to add one more layer, and I'm sure he's going to talk about this, but Todd is on the repowering side, which means he's seen a ton of sites that were built by other people. And some of them are, these are designed and engineered by humans. They're not always perfect. They're working around various constraints and things like that. And things change, technology changes, layouts change, etc. But I think it's always really interesting when you have somebody like that at your fingertips, who has seen the arc and has learned from other people's mistakes and is applying the lessons that he knows from today. So, with that, I'm just so excited to hear from you, Todd, and thank you very much for joining us. And just know that, these are often asynchronous. We get a lot more traffic from people who are excited to learn about this after the fact that they just can't make it at the time. So it's a really powerful and important piece of our portfolio that helps students to kind of peer through the lens into what the future might hold for them. So with that, I'll let you take the reins, and then I'll come back with a bunch of questions. If you know, fill in if other people don't want to jump in right away. Okay. Thanks for joining us.
Excellent. Yes, yes. Thank you so much, Charles, and appreciate those kind words. Also want to thank, Repowering Schools organization for having me today to speak about repower. You're absolutely right. I did join Mortenson in 2008, and we'll talk about that in a little bit of my career here shortly. So again, thank you everybody for allowing me the opportunity to speak on behalf of the industry and Mortenson and talk a little bit about my experience in wind and then also in the repower space. So at Mortenson, we like to start all meetings with a safety or culture moment. And what that is just, it's a time for all of us to just reflect on our real life examples of how we can help everybody be safer. Safety is a huge part of the Mortenson culture. And we use this time to just relate amongst our peers and take lessons learned from our lives or things that we've seen on the project sites and share them in the meeting to be able to just help improve the safety of everybody. And so today, my safety culture or my safety moment is just focused on weather awareness. It is the springtime in the United States. It's a beautiful time for many places. But as we all know, with the springtime also comes some pretty turbulent weather. Depending on if you're in the Midwest, you get lots of thunderstorms. I personally live in Nashville. We get lots of thunderstorms and, of course, are prone to tornadoes. And earlier this week, I know that there was some heavy rains and flooding down in the Texas and in the Southwest. And then I even saw something that was really wild, which was fires, and there was fire danger in the East Coast. I think it was New Jersey. So springtime brings a lot of great things, but it also does bring some severe weather. So stay weather aware. A lot of local news stations now have apps that you can join to be able to get the weather alerts for your local area. Those are great. There are also national apps that you can log into and set your location and get similar weather alerts to help you stay safe and be aware when the weather changes quickly. So that is my safety moment for today. Uh, so moving on, a little bit about my career. So as you mentioned there, I did start in 2008 with Mortenson and have been with them ever since. When I joined Mortenson, I was in the wind energy group, as I am still today. You can see my lovely photo there from the very first project I was on, which was in Texas. At that time, we were installing some GE 1.5 megawatt machines, which were a workhorse in the industry, and many of them have been installed and also repowered today. I grew up in the construction industry. My father was a home builder. I spent a lot of time early in my career working in the trades, supporting our family business there. And it was that time that I really, started to gain a passion for construction. Ultimately, I took that passion and continued to Michigan State, where I studied construction management and ultimately graduated with my Bachelor's of Science in construction management. Part of my career with Mortenson, I started out as a field engineer and have worked my way up as a project engineer, superintendent, project manager, and ultimately now to general manager within our wind group. One of the things that I like to highlight when talking to students about my career is that I have, some experience in both the project management track and also the superintendent track. And why I think that's super valuable is that the superintendents for Mortenson are, they're our field leaders. They're the people that are out there engaged with our craft workers, leading the work in its place. Project managers, as many of us know, they're behind the scenes, they're actively engaged in the project management, but they're mostly involved in the contracts, the subcontracting, working through the negotiations with the owner, but ultimately less of a field presence and more of that office administrative side. And why I think it's important, or what I really value about my career journey, is the fact that I've seen both lenses. And it's important to have both of those perspectives in order to be successful in either. And that's a little bit of my advice to students as they're thinking about their careers is, if you have that passion for the field work and want to be a superintendent, don't lose sight of the management side as well. Like in order to be a successful superintendent, you really need to understand your contract for the project. You need to understand the contracts with your subcontractors, but it's in those that you really define the overall goals of the project. And then similarly for a project manager, while you're managing to those goals, you need to understand what's happening in the field. Ultimately, it's what's happening in the field that is defining your project. You need to be just as involved in understanding what our craft workers go through, what your subcontractors are dealing with, ultimately what's happening at your project in order to management to success. So that's one of my pieces of advice for students, and one of the things that I'm really fortunate about with my career. So we already hit on the safety moment there. Jumping into a little bit more about Mortenson. So as I mentioned, safety is extremely important to Mortenson. It is quite literally, in our DNA, and really one of the things that defines us within the industry. And the reason behind that is really just the basic fact that we want everybody to be able to go home safely and in the same manner that they showed up, with just a little bit of, really extra dollars in their pocket. The business Mortenson, was founded by people that started in the trades as well. Nels Mortenson and Mort Mortenson Sr., they were active tradespeople. And with that comes a genuine care for our trade workers. And thus, we want to make sure that we're doing everything we can as an organization and as a company to let them come to work, make a good living, a great living. Really, like construction is a tremendous career, but ultimately being able to go home and see their families at the end of the day too. Like there's nothing more valuable than being able to provide that opportunity for thousands of men and women daily. So it's our commitment and our goal to make sure that we're doing everything we can to keep them safe while they're at the job site. Diving into a few more stats about Mortenson, or who Mortenson is as a company. As I mentioned, we are a third generation owned company. There are actually 4 Mortenson generations that have been in the United States. They are an immigrant family that came over in the early 1900s and started the Mortenson company. And we are currently under the third generation of leadership led by David Mortenson. We have 12 regional offices across the United States, with Nashville being the most recent. Top 22, or we're number 22 in the ENR rankings for contractors, 10,000 plus team members, and last year we had just shy of $11 billion in revenue. And this year we're forecasted to have a substantial amount of growth in our revenue as a result of the latest boom in both data centers and renewable energy. A little bit more about what we do and what we build. So a lot of people do know about Mortenson as a renewable energy contractor, but that's not all who we are. And it's actually not where we started. As I mentioned, Mortenson got its start in Minneapolis. And at that time, we were just a regular general contractor working in typical commercial projects. And from that, we have advanced into renewable energy, but we still hold on to that core group of business, building things like stadiums. We're well known for stadiums. A couple of the more recent ones that we just finished was the Allegiant Stadium in Las Vegas, and we're currently building the Las Vegas A's. They are also moving to Las Vegas as a part of their relocation, and we are building the new stadium for them there. And then we've also expanded into, we do typical office buildings, healthcare, we do power. We have a group that focuses on transmission and power substations. We also do civil work, and then, as I mentioned, data centers as well. A little bit more is just the foundation. Going back to Mortenson is not just a general contractor. We were originally, kind of found on by people that worked in the trades. And we think that it is our self-performed capabilities that really helps to set us apart from some of the other contractors in the industry. We have a tremendous self-perform group of people. Notably in the wind business, we self-perform a lot of our foundation work, a lot of the steel erection associated with the wind turbine construction. On the solar side, very similar. We do a lot of our own work in that side of the business. And then on the commercial side, we self-perform a lot of concrete. But ultimately, Mortenson, we like to stay close to the heart of the business, which is that self-performed capability and the craft workers that help make it possible. A few more slides just about Mortenson. One of the things that also helps to differentiate Mortenson in the market and is what is also being fueled by this recent data center boom is, advancement in construction, utilizing both artificial intelligence and design for manufacturing concepts. Ultimately, the country and the industry does have a labor shortage, and the goal is always to build faster, better, and with higher quality. And in order to do that, things like design for manufacturing construction allow us to achieve those goals. And what that is that's taking more of a manufacturing mindset into the construction space and trying to see how we can take things within the construction world, standardize them, and build them within factories. So that way, when we mobilize them to the project site, the installation is ultimately faster, more seamless, allowing us to build and get projects online quicker. Mortenson does that. We have a couple of our own innovation labs and also manufacturing facilities where we manufacture things like this precast duct bank, which is used at our data centers. We are able to install, hundreds to thousands of linear feet per day of these precast duct banks, whereas the traditional models were more, you would excavate the hole, you would install all of the duct banks working, down in that excavation to have to, piece together the conduit as you see in this fashion. After you got that set in place, you would then come back and pour the concrete, let that concrete cure, have to backfill. Even just describing it, you can hear kind of all the steps associated with it and how it can take a long time. We've designed a way to be able to manufacture that in a building, ship it to site, and as you can see, we pick it right off the truck, set it into the trench, basically connect it, and then keep on going. And now that duct bank is pretty much ready to go. I think this is the last little piece about Mortenson. Charles, you hit on it there at the intro, talking about my career, 18 years with Mortenson, one company, and you kind of teed this piece up. I couldn't even have planted it any better. But yes, one of the things that really helps Mortenson stand apart is the fact that people do truly enjoy working for Mortenson. As you can see, we've had 35 best workplace awards in the last 5 years. When you speak to Mortenson, or when you speak to people like myself and others within Mortenson, the common theme that people say is that family structure of the foundation of the company, being a family-owned business, truly resonates within the culture of the company as well. Even though we have grown tremendously in the last handful of years, the company does very much still feel like a family-focused company, caring for its people, and that really resonates with everyone and what helps to contribute to these best workplace awards, but also very much like myself, people that have long tenured careers with Mortenson. Okay, getting into a little bit more now of the energy side of our business. This is just a quick map showing all of the different states that Mortenson has worked on. You can see within Mortenson, we also work in many different renewable technologies. Wind was the original business that Mortenson opened back in 1995. And from that, we were able to use, basically a lot of the lessons learned, a lot of the leadership from that original, founding to then expand into the other renewable technologies. We started into solar in 2009, moving into power delivery, energy storage, EV charging, now data centers, as I mentioned, and even microgrids. So it's a tremendous story from how one technology was really able to help grow the Mortenson business, help to diversify our business, but it led to additional growth and opportunities for our team members. Few wind specific stats for Mortenson. We have installed over 43 gigawatts over our 30 years. I guess now we are technically into year 31. We are the number 2 wind contractor. So give or take every year, Mortenson is usually within the top 2. There's really 3 big players within the wind energy space, and Mortenson is consistently within that top ranking. And as you can see, 285 plus projects completed on the wind side. Looking a little bit more at our repower project specifically, repower, we started with our first project in 2017, and I was a project manager at that time. Was the very first project that Mortenson did for repower, and was the early kind of spawnings of what ultimately has become our repower market. Since that time, we have finished over 50 repower projects, totaling over 7 gigawatts of power or wind turbines repowered. And I have the pleasure of actually being involved in almost all of those 50 projects over the course of my career. As I mentioned, I was the project manager on that very first project. And from that time, they just kind of kept me involved in the repower, the next ones, and then the next ones. And then, 5, 7, 9 years later, I've grown into the general manager focused on that market. So it's been a lot of fun. As you can see, I've spent a lot of time across the country in support of those projects, and it's been quite a career. Okay. So before we get into a little bit more of the technical details about repower and kind of what it is, I wanted to make sure that we just had a baseline understanding of maybe things that we'll talk about here. So apologies if this looks a little elementary for some, but thought it would be helpful just to make sure that we're all aligned when we're talking about different components, that people have a good conceptual idea of what that is. So starting with, basically your general wind turbine. There's the common elements, things like the blades and the hub, which comprise of the entire rotor when you speak of the entire assembly. The nacelle is often referred to as the brain of the operations. It is that big piece that sits on top. It's where the energy is produced. Inside of that nacelle is typically a low speed shaft, which is what is spinning from that rotor. That low speed shaft is connected to a gearbox, which takes that low speed movement into a high speed movement, which is ultimately connected to the generator. And that's what then creates the electricity that goes out to the grid. A few other things that are of note within the repower kind of conversation would be, yaw drives, yaw motors. So those are the things that help to pivot the wind turbine into the wind and making sure that it's always basically facing into the wind. Also the main bearing and controller. The controller is the computer system that helps to operate the wind turbine, and that's the other kind of piece that is pretty critical to the operations. So now that we have an understanding of the components, we will get into, so what is repower? Quite plainly, repowering is the term that is used to describe the overall enhancement or modernization of old or outdated equipment. Repowering is thinking of like doing a home improvement project on your house, right? You have some old cabinets, you have some old tile, and you want to improve it and make it better. And that's what we're essentially doing with wind turbines during a repower project. Repowering comes in 2 forms, I'll call it. And that is, one is what's called a partial repower. So a partial repower really focuses on the upgrading of specific components. So this gets into replacing things like the gearbox or the generator. Oftentimes, it's also paired with replacement of the rotor. One of the major improvements associated with repower is the fact that you can install a larger rotor, which ultimately helps with the overall energy production. And then the other type of repowering is what's called full repowering. Full repowering is the complete demolition of an existing wind farm. So you take all of those, usually this occurs with technologies that are really old. So probably in the 15 to 20 or greater year lifespan. Basically, the equipment is so old that it doesn't have parts that you can use to improve it. And so the idea there is to leverage the location, because a lot of those early wind farms were built in areas where the wind is the best. And so you want to utilize that location. So what you do is a full repower, which is basically demolition of all of the existing assets. And then you rebuild in the same general area with newer, better equipment, leveraging things like the transmission lines that would already be in place, or maybe the substation that the old assets were connected to. So it allows you to leverage some of the infrastructure that already exists, but replacing the turbines themselves with newer, higher efficiency turbines. Okay, so going a little bit deeper now into partial repower. Even within the partial repower category, there are kind of two options here as well. The first one is what's called a major retrofit or a main component exchange. And this gets into taking out the pieces inside of that nacelle. Very similar to thinking of cars, for example, right? You're taking out the engine, you're not replacing the entire car. You're thinking of what is valuable or what is most likely to wear out, and you're replacing that with something that's newer, more efficient. So in that space, for partial repowers, common things that do get replaced are things like the drivetrain. The drivetrain is the combination of the gearbox and the main shaft. Generator, a lot of times the generators also need to be replaced. The generator frame can sometimes be replaced, and then ultimately, again, the hub and the blades for the entire rotor. The reason why the rotors are typically replaced is because the blades and the fiberglass tend to wear out over time. But the other big piece there is the overall size of the rotor. Some of these turbines that were built there back in like 2008 on my very first one, they had a 77-meter diameter rotor, which was big at the time. But even that same generation of GE wind turbine eventually was able to increase to a 97-meter rotor. So with repower, we're able to take off that old 77-meter rotor and put on a new 97-meter rotor. And the reason why that's important is because ultimately, the larger the rotor diameter allows for the greater efficiency of converting the wind energy into electrical energy. So the larger rotor essentially allows the wind turbine to create more power more often, which helps with the reliability of wind energy overall. When it comes to the major retrofit or main component exchange, typically the collection system and the foundations do not need to be improved or enhanced. The idea there again is that you're just replacing parts that commonly wear out with new ones, more efficient ones, thus increasing the overall longevity of that asset. The second type of partial repower is what's called a full nacelle replacement. And as the name suggests, that type of project is where you replace that entire nacelle that's up top. Much easier to do, but as one of the drawbacks or one of the concerns with a full nacelle replacement is that commonly those can lead to potential needs for upgrading the collection system and the foundation. That larger nacelle typically comes with a little bit greater loading, and these foundations, some of them would be okay. You know, when the engineers analyze the foundations for repowering, sometimes the foundations will check out and they'll still be okay. And sometimes they need to be enhanced or upgraded in order to support those additional loads. And that's what you see a little bit here in the picture to the right. This is a foundation that's being prepped for what's referred to as a foundation collar. And as you can kind of think of from the name, what that is it's an installation of steel and concrete collar around that existing pedestal that helps to reinforce that connection of the pedestal to the base and provide the strength and the stiffness that it needs to handle the new loads from the new turbines. Another thing that is very common for a full nacelle replacement is the conversion of old or outdated equipment. So very much like cars, I'm going to keep using that analogy. Over the history of time, there are different equipment manufacturers that have, been in the space producing and providing equipment for wind energy, but maybe they are not there anymore. And those assets are still operational, but they just don't, you don't have somebody to call up to and get, new parts for that particular machine. So what some of the OEMs are able to do is basically utilize that tower, but take the old nacelle off and put a new nacelle on. And so this allows, for assets to continue to be used much beyond their original lifespan. But it also allows for the reuse of the tower, the roads, the collection system, everything else that's supporting that asset. But you get the same benefits of a repower. So that's a great option for owners that have assets that were originally produced by manufacturers that may not support the U.S. anymore, or they just may not be around anymore. So here we have a little video showing what partial repower, and this is main component exchange, what that looks like. And you gotta love the Mortenson tag at the end. Oops.
Totally. This looks like it's done from a
There we go.
drone. How did that drone stay up that long? Or was it? Who
What's
knows? That looks like it was done from a drone, but that takes a little while to do what you just did.
Yeah. It was filmed from a drone. There was a few videos that were stitched together to kind of create that. But that video, one of the things I want to hit on that was shown there, like I mentioned, it was the main component exchange, and that's one of the things that's pretty different about repower is you saw that the individual components were being replaced within the nacelle. You can see the people standing up top. The nacelle lid was off, and people were being able to, or we were replacing the drivetrain, the generator, and then what you saw was at the end there was, of course, the rotor being installed. So pretty neat to just see kind of that difference, and that's pretty foundational to what repower has been. And I say that just because a lot of the new repowers are going into the full nacelle replacement for ease. Next, we're moving on to talk about just full repower real quick. And I see that I'm getting a little short on time, so I'm going to speed it up a little bit to make sure we have time for questions at the end. But full repowering, as I had mentioned earlier, is just talking about the complete demolition of an existing wind farm and the rebuild in the exact same location with newer modern assets. And again, what this allows for us to do is say you have a 100 megawatt wind farm that was built originally, that may have somewhere in the neighborhood of 60, 70 turbines in order to achieve that 100 megawatts. Like the first project I was on, those units produced 1.5 megawatts each. And so, to get to 100 megawatts, you're somewhere in that neighborhood of, 70 turbines or so. The units that we're building nowadays, most of them are 3 to 4 megawatts a piece, and some are even larger for the onshore market. So in order to maintain that same 100 megawatts, you need much fewer turbines. The fewer turbines just inherently gives you less disturbance with the local landowners, less chance of maintenance and issues associated with that, and ultimately just allows for better reliability. And real quick here, we have a video just showing one of the big pieces about a full repower is the demolition, which is the felling of the towers, which I will show you now.
Oh, you actually are doing that. I was like, no, 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 please don't. Oh no. Oh, I remember when they did that with the Mod 5B out in Hawaii, and I thought they just did it because there's only one of them. That's so sad.
It is a bit sad, but at the same time, I would say it's also one of those visions of like, call it from death, life, a new life can begin.
Yeah, yeah, yeah.
What that is a reality of repower and the market, right? A lot of those wind turbines are really old, and quite honestly, the safest way to take them down is to do what was just shown, which is what we call felling of the towers. It allows for us to take them down with the quite literally the safest way, because it's much more controlled to do a demolition like that than it is to mobilize cranes and people and actually have to disassemble. But it also then allows for those ones to be removed, and like I said, new units can be built in their place, ultimately maintaining the generation of the wind farm, but fewer turbines, which is usually received as a good thing by the landowners. So really, we've kind of talked about what is repower, and now just hitting on the why. Why are we even doing this? A lot of times it's about just higher energy production. So as I mentioned, with upgrading these parts, you are making the individual turbines just more efficient and operating more often, which ultimately just allows for greater energy production, both at peak times and at low times. It's just providing general or better reliability to the grid and overall just more energy output. Efficiency gains. Same thing in terms of like getting to that additional generation and output. The new units are just operating more efficiently. Better efficiency is just better for energy production. Infrastructure savings, you're able to reuse a lot of the roads, the collection system, the substations that were built 10, 20, 30 years ago. By extending those lifespans, you're just getting more return on the investment of those assets. And then the extended life. So repowering also helps to restart the clock on a wind farm's useful life. When a new farm is built, and when a lot of these wind farms were built that we are now repowering, the expected life expectancy was about 20 years. Most of them that we're going into and repowering are somewhere in that 10 to 15 year of age range. And when we repower, they get certified for an additional 20 years. So now, you could be having the total lifespan of those assets in the neighborhood of 25 to 30 years compared to the original 20 years that was planned for it. Few more items is just reduced maintenance cost. Again, you are replacing kind of components that typically wear out over time. The gearbox is very common to wear out over time, and you're replacing that with a new gearbox. So you're kind of getting ahead of some of the maintenance expenses. And then you're also just using parts that are most likely have been engineered over the last 10 years to just be more resilient and ultimately provide a better machine for the owners. Environmental and social benefits. As I mentioned, in the full repowering space, you're usually reducing the total number of turbines on a project, thus just giving more land back to the local landowners. Less turbines usually means less noise, less disturbance, and that's usually well received by the local community. And another benefit is that, these projects are typically built, or when we're repowering, we're in an area where the community has already adopted, life, I'll call it, with a wind farm. Like they are usually, well received because they have been having these assets in their communities for years. And so when you go in there and you repower it, it's kind of more of the same rather than going into, areas where there's new construction and thus having to deal with the relations of just building something new in that area. And then the last piece is just the economic incentives. There are what is called the production tax credit, which is a subsidy that is supporting renewable energy, and that is available with these repowering projects. So owners can requalify for the production tax credit and thus help with the overall economics of their projects. Last piece to hit on here, as I know it's a big topic in the current conversation associated with repower and wind, but it ultimately gets down to the disposal of the old equipment. There's a lot of negative press that has been talked about in terms of old wind turbine blades. And quite honestly, like the news is not fake, but it's just outdated. Early on, 5-10-ish years ago, the blades were originally sent to landfills. But from there, there's been a lot of entrepreneurs that have come around and said, hey, we think we can do something better with this material. And nowadays, I don't know of a single project within Mortenson space where blades are going to the landfill. There are recycling options available for all of the blades in the fiberglass material. And that is, the diligence that the industry has taken, thanks to the entrepreneurs that have been looking for reuse opportunities. Some of those reuse opportunities are thermal processing. So you can take the old fiberglass, send it to cement kilns, and it's an alternative fuel for the cement kilns. There's also things like a chemical or pyrolysis that ultimately can either think of like dissolve the blade and the materials into other usable liquids, ultimately getting to the pure fiberglass fibers. And then there's other, what we call the creative repurposing, which is similar to the image that you see here. But there's people that take the old blades, cut them up, and redesign them into, as you see, benches here, but useful aesthetics for parks. Some people have looked at, I've seen articles of people taking them and turning them into fence posts. I think even tiny homes is out there, but there's a lot of reuse options for the old equipment. The majority, as the stat is here, like over 90% of the wind turbine by weight is recyclable. The few things that aren't recyclable are some things like styrofoams. There's different foams and things like that inside of the construction of the blades that doesn't have a good recycling option currently. And lastly here, just a few, ending it with just a few wind myths that, are debunked really. I have a feeling that anybody that is listening to this is an advocate for wind and renewable energies. And just with that, there's sometimes just misinformation that we all need to, help to correct. And I've listed out a couple of those here. So those will be in the slides and we can share those, but with only a few minutes left, I will open it up to questions.
Yeah, thank you, Todd. That's an amazing overview and incredibly rich and powerful, I think. It's just wonderful. So with that, I want to first open it up to anyone on the call who is interested. Just raise your hand and I'll call on you. And then failing that, I have enough to run us out a ways. Melissa, what do you got?
Yes, I did have a question. Firstly, I did greatly appreciate you like laying out the fundamentals of repowering and partial repowering and like discussing the new technologies that are being integrated into different turbine components. And more precisely, you do have a very unique perspective starting as a field engineer and then superintendent, project manager, and now general manager. And so as an engineering student myself, I was curious if you had always anticipated moving along these leadership roles and or if you took certain steps along the way to build both like the technical recs necessary as well as like the management skills to get to where you are now.
Yeah, excellent question, and thank you, Melissa. The short answer is I didn't really have a good plan. Um, as I mentioned, like I started my career in the trades, going back to my childhood with my dad building homes, and that passion is what kept me in construction, and that's why my original career path did take me along the superintendent route. And I still love it to this day. I mean, one of my favorite things is getting to projects and just shaking hands with the people that are still building our projects today. But that love is really what started me down the superintendent career path. And it was from that time, though, that I also started looking at like kind of what do I want from my career, and how can I just continue to advance both myself personally and the company. And that's where I started to pivot into project management. One of the things that I love about my time as a superintendent is superintendents they spend so much time in the field working with people, resolving issues. You get really good at creating those good soft people skills. Like you are our superintendents on an average day, they're coordinating the work with, depending on the size of the project, probably 150 to 200 craft workers. And on the larger projects, that can push upwards to 300 craft workers. So as you can imagine, that's just a whole lot of relationship management. So you get really good at, creating strong people skills and also ultimately issue management. And that is really helpful then when you switch over to the project management path, because you have a little bit different relationships in that you're managing the relationships with customers, but those same skills are still important in terms of learning how to understand what's important to people, how to communicate well, communicate your point, and being able to ultimately resolve conflict. Thankfully, we don't have to deal with 300 different owners. There's usually fewer people on that side, but some of those skills are still useful even in the project management path. So I would say for people young earlier in their career, is the best thing is just to not be too I guess punny, but is to quote Ted Lasso and be curious. Be curious early on in your career. Go out there, learn what you like, what you don't like, but ask questions, get involved, get engaged. And from that, you're going to just start to develop like what ultimately is important to you. What are you more passionate about? Is it that project manager path? Is it the superintendent path? Is it design phase? One of the things that we didn't get much time to hit on is like there's a whole bunch of people that help support not only myself, but our people in the field. There's scheduling services, there's estimating, there's design phase, there's safety, there's quality. There's a lot of other career paths that support the projects as well. And it's kind of to every person to just have their own journey and find what they're passionate about, and ultimately continue down that path.
That's so wonderful. Amara, you've got a question? Uh-oh.
Yes, can you hear me now?
Yes.
Yes.
Yes, thank you, Todd. I think it is a very nice presentation. And this is Amara. I think I'm not from US. I'm from Addis Ababa University. I'm a full-time lecturer and also electrical power engineer by training. So I think one of my question is already forwarded on the group chat part. So one of the question is, let's say when you do this scale type of wind turbine projects, one of the key part is the safety issue that you have presented before. So based on project estimation, and how much percentage of the cost of a project can actually forwarded to the safety part according to your company or according to the USA standard. The other question will be about repowering. I think repowering is one of the good and also a very efficient way of reutilizing specifically the component as well as the infrastructure for energy generation. So my question is going to be about the full repowering. It's it is a partial and also one of the full repowering. On both cases, when you repower, of course, the intention will be not only changing the infrastructure, also increasing the efficiency as well as the capacity. So when we increase the capacity, we are increasing the power. When we increase the power, we are actually increasing the cable size. And also, we also increasing the generator, the substations. So, of course, there is going to be a change of substation as well as those components on the infrastructure, especially on the repowering case. And also on one of what your slide, what you have actually suggested that so we can reutilize the substation. Of course, we can reutilize the substation, the area, and also the component. But of course, when you repower, especially full repower, definitely there is a point you can increase the capacity of each wind turbine. So as a result, you should change the switch gears, and also you have to change the transformers, and also even the underground cable. So how we can say repowering when we say full demolishing, and also using that. I'm actually asking about the nomination about repower, full repowering with a full demolition. So how you can actually manage that part. Thank you, Todd. It is a very nice presentation.
Yeah, excellent. Great questions, Amari. So just real quick on the first one, talking about safety. The way Mortenson approaches the work is like, it's not like we estimate the cost to do the work and then the cost of safety, right? Safety is built into the way we build. So it's just an inherent part of how we estimate. It's not its own kind of separate cost. Everything that we do from a safety standpoint is a part of the work. And then when we're estimating a project, like it's just the built-in cost associated with that work. It's not a separate piece that like we necessarily have a percentage that is focused on safety. Your second kind of question, talking about the full repower options, you did hit on some good points, and we are also kind of talking in very generalized terms, but typically one of the benefits of a full repower project is you're trying to utilize the fact that there's a generator. So wind farms are just considered generators on the utility side. So they have an agreement as a generator to basically put energy onto the grid. And what a full repower allows for is for basically developers and owners to not have to renegotiate that generator interconnect to the grid. Usually when they apply for those permits early on with the different regional transmission providers, those terms could be much beyond the original 20 years of the wind farm. It could be 50 years. So what they're leveraging there is the fact that they already have approval to put energy onto the grid, and now they're just creating a better, more reliable source. Going back to like our 100 megawatt example in that full repower, there could be options very much out there for people to say, yeah, I want to put more than 100 megawatts on the grid. But one of the benefits of a full repower is to kind of fast track and cut through that red tape, because they already have that approval for that generator of 100 megawatts to go onto the grid. They can demolish the old wind farm, build a new, more efficient wind farm at that same 100 megawatt capacity, and thus interconnect into the grid much faster. And one of the big things that's also in our industry right now is like permitting reform. And a lot of that permitting reform is focused on just the current time it takes for developers to put a request into the transmission operators for things like a generator interconnect, and the delays in the approval process that it's taking. Sometimes they're 5 to 7 to even like 10 years. So that permitting timeline is kind of is one of the things that you don't have to worry about in a full repower scenario. But yes, depending on the extent of the full repower, you're right that the collection system is usually replaced. The substation may or may not be reusable. The big things that you're leveraging there is the fact that you already, that wind farm asset already has approval to generate onto the grid. So you have there's probably some transmission, some point of interconnect that you're already leveraging that's in place. And that's the benefit of the full repower.
Todd, that's an amazing wrap up. We so appreciate your time today. I think we could have gone on for probably another hour, and you would have just kept us completely entranced. And we're just going to have to do that again later because we want to be respectful. But thank you again very much. Thank you to Mortenson for giving you both the time and the skills and the career, and for lending us Jamie too to make sure that everything worked okay today. We really appreciate that.
Yeah.
It's amazing.
Thank you. Thank you, Charles. Thank you, everybody. Happy to answer questions, on the side. Please reach out to us, and wish you all the best of luck in your careers. And, please check out Mortenson's career webpage if you're interested in working for Mortenson.
Sounds good.
Amazing.
Thank you. Thank you,
Thank you,
everybody, for
guys.
coming.
Bye.
Take care.
Thank you so much.
Okay.
Bye.
Goodbye.